Okay, dear all, today we will start on a limit, the definitions of a limit, or chapter 3 for the course of applied mathematics 1. Now let us, in this part, we will see definitions of a limit using the formal or epsilon delta definitions and the informal one. That means the intuitive definitions. So what is the intuitive definitions? As well as what is the epsilon delta definitions, with different example can be discussed in this part. Dear all, don't forget to subscribe, like, comment, share these channels. And now let us start from Unit 3, which is a limit and continuity. Definitions of a limit. What is the definitions of a limit? There are, as I told you, that there are two types of definitions of a limit, that is intuitive definitions of a limit or the informal definitions. Now, using informal definitions, a limit can be defined as in such a way. When we say that L is the limit of f of x as x approaches to L, we mean that f of x gets close to L as x gets close to A, and we can write symbolically in such a way: limit of f of x as x approaches A is equals to L, or f of x approaches to L as x goes to A. This is the informal definitions of a limit. Example. That means, for example, if you see if x gets close to 2, then x plus 2 gets what? Close to 2. That means limit of x plus 2 as x goes to 2 is, which is 4. This is which is using one of technique of computing a limit, which is called direct substitutions. By substituting directly, we have here 2 plus 2, which is 4. Therefore, limit of x plus 2 as x goes to 2 is, which is 4. Example 2. If x gets close to 2, then x minus 2 over x squared minus 4 gets close to what? 1 over 4. In fact, that the function is not even exist at x is equals to 2. This is simply by factorizing this x squared minus 4. That means this can be written as x minus 2 over x minus 2 times x minus 4, for x is different from 2. X minus 2 is cancelled by x minus, and we left what? 1 over x plus 2. So that these functions as x goes to 1 over x plus 2 gets close to what? 1 over 4. The second definitions of a limit is called precise definitions of a limit, which is formal definitions of a limit, or in other ways, this is called epsilon delta definitions of a limit. So what's the definitions of this, the formal one? Now the definition says that let f be a function defined at each point of some open interval containing A, except possibly at A itself. Then the number L is the limit of f of x as x approaches to A. If for every number epsilon greater than 0, there is a number delta greater than 0, such that if 0 is less than absolute value of x minus A less than delta, then absolute value of f of x minus L is less than epsilon. This is called the formal definitions of a limit. That means if L is the limit of f of x as x approaches to A, then we can write as a limit of f of x as x goes to A is equals to L. This is called formal definitions of a limit. In other ways, we can define it as like this. Let f of x be a function defined on interval that contains x is equals to A, except possibly at x is equals to A. Then we say that limit of f of x as x goes to A is L if for every number epsilon greater than 0, there is some number delta greater than 0, such that absolute value of f of x minus L less than epsilon whenever 0 is less than absolute value of x minus A less than delta. In other ways, this can be defined as for every epsilon greater than 0, there is some number delta greater than 0, such that 0 is less than absolute value of x minus L is than delta, implies that absolute value of f of x minus L is less than epsilon. For example, use epsilon delta definitions to show that a limit of 2x minus 3 as x goes to 1 is minus 1. This is using the direct substitution. We have what 2 times 1 minus 3, which is 4. 2 minus 3, which is minus 1. Therefore, limit of twice of x minus 3 as x goes to 1 is which is minus 1. So how can we prove this limit of 2x minus 3 as x goes to 1 is minus 1 using epsilon delta definitions? Now, using the definitions, we can prove that let epsilon is greater than 0. Then we need to find delta greater than 0 such that if 0 is less than absolute value of x minus L less than delta, then absolute value of f of x minus L less than epsilon. That's simply substituting a is equals to 1, f of x is equals to twice of x minus 3, and L is equals to minus 1. Here we have minus 1. So that this becomes, if 0 is less than absolute value of x minus 1 less than delta, then absolute value of twice of x minus 3 minus 1. Here we left minus here in the bracket. This is less than epsilon. Again, this is the same as if 0 is less than absolute value of x minus 1 is less than delta, then absolute value of twice of x minus 2 is less than epsilon, because here 2x minus 3, here we have minus which is plus 1. So minus 3 plus 1 is minus 2, so we have absolute value of twice of x minus 2 less than epsilon. Again, this is the same as if 0 is less than absolute value of x minus 1 less than delta, then 2 into absolute value of x minus 1 is less than epsilon. Why? Because twice of x minus 2 we have a common 2, then 2 into x minus 1. So 2 absolute value of 2 is which is 2, therefore we have 2 times absolute value of x minus 1 less than epsilon. Again, this becomes if 0 is less than absolute value of x minus 1 is less than delta, then absolute value of x minus 1 is less than epsilon over 2. By dividing both sides by 2, then we have absolute value of x minus 1 is less than epsilon over 2. So compare the left and the right hand side here. Absolute value of x minus 1 is less than delta. Absolute value of x minus 1 is less than epsilon over 2. So what is the values of delta? Then simply we choose delta as what? Epsilon over 2. So let us recheck if this is true or not. Now, if delta is equals to epsilon over 2, then simply substituting in the place of delta by epsilon over 2, then we have that absolute value of x minus 1 is less than delta here, but our delta is epsilon over 2, therefore absolute value of x minus 1 less than delta is equals to epsilon over 2. That means absolute value of x minus 1 is less than epsilon over 2. Multiply both sides by 2, then 2 into absolute value of x minus 1 is less than epsilon. Again, this if 2 becomes in absolute value, then we have that absolute value of twice of x minus 2. Again, minus 3 is the same as minus 3 plus 1, so we have that absolute value of twice of x minus 3 minus 1 is less than epsilon. But this is the same as this is the same as which is a limit of twice of x minus 3 as x goes to 1 is equals 1 using the definitions. Example number 4. Prove that limit of 3 times x minus 2 as x goes to 2 is 4 using epsilon delta definitions. So here, using the formal definitions of limits by identifying what is a, what is f of x, and what is L, then by applying the epsilon delta definitions, we can prove like this. For every epsilon greater than 0, we need to find a corresponding number delta greater than 0 such that absolute value of 3x minus 2 minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 less than delta. This is the same as what we have seen in the previous example. Or we can write this in other ways. We can write this as if 0 is less than absolute value of x minus 2 less than delta, then absolute value of f of x minus 2 is less than 4. As I told you that our a is 2 and f of x is 3x minus 2 and L is 4. So by using the definitions, then we can rewrite this above inequality in such a way. Absolute value of 3x minus 2 minus 4 is less than epsilon if and only if, since minus 2 minus 4 is which is minus 6, so we have absolute value of 3x minus 6 is less than epsilon. Again, here we have a common 3, so that we have absolute value of 3 into x minus 2 is less than epsilon. But the absolute value of 3 is which is 3, so we have 3 into absolute value of x minus less than epsilon. Dividing both sides by 3, we have that absolute value of x minus 2 is less than epsilon over 2. Then compare the left and the right hand sides. Then our delta becomes what? Epsilon over 3. So we need to choose that, or the required positive corresponding numbers for epsilon greater than 0 for delta greater than 0 is which is epsilon over 2. Since epsilon is positive or greater than 0, so our delta is also greater than 0 because epsilon over 3 is which is positive. So let us check it. Is this a true or not? Now to check this, whenever 0 is less than absolute value of x minus 2 is less than delta is equals to epsilon over 3, then we get that absolute value of x minus 2 less than epsilon over 3 implies that both sides multiply by 3, then we have 3 into absolute value of x minus 2 is less than epsilon. Again, multiplying both sides this by 3 in the inner part of the first value, we have absolute value of 3 times x minus 6 is less than epsilon. But minus 6 is the same as minus 2 minus 4, so that we have absolute value of 3x minus 2 minus 4 is less than epsilon, implies that limit of that means absolute value of his absolute value of 3x minus 2 minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 less than delta, implies that limit of 3x minus 2 is as x approaches 2 is which is 4. Example number 5. Prove that limit of 1 minus twice of x as x goes to 3 is which is minus 5. Now using here we have that our a is which is 3, our f of x is 1 minus twice of x, and our L is minus 5. So use the epsilon delta definitions. Now as solutions we have that let epsilon be positive number or greater than 0. We need to find a positive number delta greater than 0 such that absolute value of f of x minus L less than epsilon whenever 0 is less than absolute value of x minus L less than delta. Or in other words, if 0 is less than absolute value of x minus L less than delta, then absolute value of f of x minus L less than epsilon. So in other ways, we can write this as absolute value 1 minus twice of x minus 5 is less than epsilon whenever 0 is less than absolute value of x minus 3 less than delta by substituting the corresponding values for a, L, and f of x. But this absolute value of 1 minus twice of x minus 5 is the same as absolute value of 6 minus twice of x. Here we have minus 2 as a common, so we have absolute value of minus 2 into x minus 3. But absolute value of minus 2 is which is positive 2, so we have 2 times absolute value of x minus 3. Therefore, we want to 2 times absolute value of x minus 3 is less than 3 epsilon whenever 0 is less than absolute value of x minus 3 less than delta. Again, dividing both sides by 2, we have that absolute value of x minus 3 is less than epsilon over 2 whenever 0 is less than absolute value of x minus 3 less than delta. Again, compare the right and the left hand sides. That means absolute value of x minus 3 is less than epsilon over 2. Absolute value of x minus 3 is less than delta. Then our delta becomes what? Epsilon over 2. So this suggests that we should choose delta is equals to epsilon over 2. Let us check it. Given epsilon greater than 0, choose delta epsilon over 2. If 0 is less than absolute value of x minus 3 is less than delta is equals to epsilon over 2, then absolute value of 1 minus twice of x minus 5 is the same as absolute value of 6 minus twice of x, equal with absolute value of minus 2 into x minus 3. Again, this is the same as 2 into absolute value of x minus 3, which is the same as this is 2 times epsilon over 2. Then 2 is cancelled by 2, then we have epsilon. This absolute value of 1 minus twice of x minus 5 is less than epsilon whenever 0 is less than absolute value of x minus 3 less than delta. Therefore, by the definitions of epsilon delta of a limit, we have a limit of 1 minus twice of x as x goes to 3 is minus 5. Let us see another example. Prove the following limit using formal definitions of a limit or epsilon delta definitions. A. Limit of square root of x as x goes to a is square root of square root of a. So using epsilon delta definitions, let us prove it. Now, so solutions for this. A. For every epsilon greater than 0, we need to find a corresponding delta greater than 0. Such that if 0 is less than absolute value of x minus a is less than delta, then absolute value of square root of x minus absolute value of a is less than epsilon. Here, on the left hand side, we have the term absolute value of x minus a, but here square root of x minus square root of a. So we need something, or this expression should be changed into what? Absolute value of x minus a times some constant number, so that let us we start from square root of x minus square root of a. What is absolute value of square root of x minus square root of a? Now, absolute value of x square root of x minus square root of a is the same as, by rationalizations, we have square root of x minus square root of a times square root of x plus square root of a over square root of x plus square root of, since this is 1, isn't it? So square root of x plus a over square root of x plus a, which is 1. So simply we multiply this square root of x minus square root of a by 1. So what it looks like. Then multiplying this square root of x minus square root of a times square root of x minus square root of a times square root of x plus square root of a, the whole over square root of x plus square root of a. Now by simplifying this, we have absolute value of x minus a over square root of x plus square root of a. Why? Because this, since this is, which is square root of x minus square root of a times square root of x plus square root of a, using the rule that means a minus b times a plus b, then which is the same as a square minus b square. So this becomes what? X minus a, the whole over this square root of x plus square root of a. So this is less than or equal to absolute value of x minus this term, absolute value of the whole absolute value of x minus a over square root of x plus square root of a is less than or equal to absolute value of x minus a over square root of a, since square root of x plus square root of a is what? Greater than or equal to square root of a. And also 1 over square root of x plus square root of a is less than 1 over square root of a. As a result, this is the same as 1 over square root of a into absolute value of x minus a less than epsilon. Since delta must be small enough which is between a minus delta and a plus delta, so that by comparing the above, that means square root of absolute value of square root of x minus square root of a is less than or equal to this time 1 over square root of a times absolute value of x minus a less than epsilon. Again, this is the same as this absolute value of x minus a. By multiplying this both sides by square root of a, we have absolute value of this term, absolute value of x minus a less than or equal to epsilon times square root of a. Now, by comparing the left and the right hand side, we choose that delta as epsilon over epsilon times square root of a. Now let us check is this a true. Now, for given epsilon greater than 0, our delta is epsilon over epsilon times square root of a. So if 0 is less than absolute value of x minus a is less than delta, which is epsilon times square root of a, then we have absolute value of square root of x minus square root of a, which is the same as absolute value of square root of x minus square root of a times square root of x plus square root of a, the whole over square root of x plus square root of a. Again, this is the same as absolute value of x minus a over square root of x plus square root of a, because this, when multiply this, it becomes x minus a. So this term is less than or equal to absolute value of x minus a over square root of a. Again, since 1 over square root of a is a real number, so absolute value of 1 over square root of a is 1 over square root of a, so we have 1 over square root of a times absolute value of x minus a. Again, this is less than 1 over square root of a times delta. Then our delta is epsilon times with epsilon times square root of a. Then square root of a cancel by square root of a, or square root of a over square root of a, which is 1. Then we have which is epsilon. So we have that limit of square root of x as x goes to a is square root of a. Questions number B. Limit of x squared as x goes to 2 is equals 4. Then using the formal definitions of a limit, we can prove as that means for a given epsilon greater than 0, we need to find delta greater than 0 such that absolute value of x squared minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 is less than delta. Don't confuse that. This is the same as 0 is less than, if 0 is less than absolute value of x minus 2 less than delta, then absolute value of x squared minus 4 less than epsilon, which is the same as this absolute value of x squared minus 4 less than epsilon whenever 0 is less than absolute value of x minus 2 less than delta. But this time, absolute value of x squared minus 4 is the same as using the rule of a minus b times a plus b, which is equal to a squared minus b squared. We have absolute value of x squared minus 4 is the same as absolute value of x minus 2 times x plus 2, which is the same as absolute value of x minus 2 times absolute value of x plus 2. But here we have only the term absolute value of x minus 2. So we should have to change this term absolute value of x plus 2 into constant number. So to change this into constant numbers, let us assume that, or let us choose that our delta 1 as is equals to 1. Now, if delta 1 is equals to 1, this term absolute value of x squared minus 4 less than epsilon whenever 0 is less than absolute value of x minus 2 less than 1, because previously we have said that 0 is for x squared minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 is less than delta. But we choose that, or we assume that our delta 1 as 1. So we have x absolute value of x squared minus 4 less than epsilon whenever 0 is less than absolute value of x minus 2 less than 1. Now here, by using the rule for absolute value of x is less than a if and only if minus a is less than x less than a, so that absolute value of x minus 2 is less than 1 if and only if minus 1 is less than x minus 2 less than 1. Again, in order to obtain the term absolute value of x plus, so we should have to add both sides 2. When we add both sides 2, then minus 1 plus 2 less than x minus 2 plus 2 less than 1 plus 2. So we have 1 less than x less than 3. Again, to get the term x plus, as I told that, we should have to add both sides 2. So we have 1 plus 1, 1 plus 2 less than x plus 2 less than 3 plus 2, which is the same as 3 is less than x plus 2 less than 5. Again, this is the same as minus 5 is less than 3. Yeah, isn't it? This is less than, again, x plus 2 less than 5. So simply, we have that absolute value of x plus 2 is less than 5. So in the previous equations, we should have to replace this term absolute value of x plus 2 by 5, so that absolute value of x squared minus 4 is equal to absolute value of x minus 2 times x plus 2, which is the same as absolute value of x minus 2 times absolute value of x plus 2. But absolute value of x plus 2 is, which is less than 5, so we have that this is less than or equal to 5 times absolute value of x minus 2, which is less than epsilon. This suggests that we should choose our delta to as this as epsilon over 5. So letting delta is the minimum of those epsilon, or the minimum of delta 1 and delta 2, our delta. So our delta is, or we let as our delta as minimum of epsilon over 5, 1. It follows that whenever 0 is less than absolute value of x minus 2 is less than delta, we have absolute value of x squared minus 4 is the same as absolute value of x minus 2 times x plus 2, which is the same as absolute value of x minus 2 times absolute value of x plus 2 is less than or equal to 5 times absolute value of x minus 2, which is less than 5 times epsilon over 5. Then this 5 is cancelled by 5, then we have this is epsilon. So absolute value of x squared minus 4 is less than epsilon whenever 0 is less than absolute value of x minus 2 less than delta. Therefore, by the definitions, we have a limit of x squared as x goes to 2, which is 4. Question number 3. Limit of 1 over x as x goes to 3 is 1 over 3. Now let us see this example. It says that for every number epsilon greater than 0, we must find the corresponding delta greater than 0 such that absolute value of f of x minus L is less than epsilon whenever 0 is less than absolute value of x minus a is less than delta. So by replacing or by identifying a, f of x, and L, and by applying the definitions, we have absolute value of 1 over x is absolute value of 1 over x minus 1 over 3 is less than epsilon whenever absolute value of x minus 3 is less than delta. That means absolute value of 1 over x minus 1 over 3 is the same as, when starting from this, 1 over x minus 1 over 3 is the same as absolute value. By crisscrossing this, then we have 3 minus x over 3 times x. Again, this is the same as absolute value of x minus 3 over 3 times x is the same as, by using a rule of absolute value for quotient functions, we have absolute value of x minus 3 over absolute value of 3 times x, which is less than epsilon. Whenever absolute value of x minus 3 is less than epsilon, then in order to change this absolute value of 3x into constant, because on the right hand side here we have only the term absolute value of x minus 3. So this term should be constant times the absolute value of x minus 3. So we should have to change this absolute value of 3x into constant. So to change this, let us start from, we choose our delta as 1. So that if delta is 1, then absolute value of x minus 3 over 3 times x is less than epsilon. Whenever absolute value of x minus 3 is less than delta, then let us choose our delta as 1. So we have absolute value of x minus 3 less than delta. We get that since our delta 1 is which is 1, so we have absolute value of x minus 3 is less than 1, then this is the same as minus 1 is less than x minus 3 less than 1, which implies that by adding both sides 3, that means minus 1 plus 3 less than x minus 3 plus 3 less than 1 plus 3, then we have 2 less than x less than 4. Again, since our term here, we have the terms 3 times 6, therefore we multiply both sides by 3, so we have 3 times 2 less than 3 times 6 less than 3 times 4, then we have what? 6 is less than 3 times x less than 12. But this term is 1 over, so we should have to say this 1 over 1 over 1 over both sides. So we have, by finding the x inverse, so we have 1 over this 1 over 2, that means 1 over 6 is greater than 1 over 3x greater than 1 over 12, so this can be rearranged as 1 over 12 is less than 1 over 3x less than 1 over 6 using inequality rule. So this is again the same as minus 1 over 6. We know that minus 1 over 6 is less than 1 over 12. Again, here by using the above, we have 1 over 12 is less than 1 over 3x less than 1 over 6. This implies that what? The whole, by taking both sides by absolute value, we have absolute value of the whole 1 over 3x is equal with, since this is the same as absolute value of 1 over absolute value of 3x, but absolute value of 1 is which is positive 1, so this is equal with 1 over absolute value of 3 times x, which is less than 1 over 6 here. So in the above term, the term 1 over absolute value of 3x should be replaced by what? 1 over 6, so that absolute value of 1 over x minus 1 over 3 is equal with absolute value of 3 minus x, by taking this 1 times 3 minus 3x, the whole over 3 times x. So this is the same as absolute value of 3 minus x over 3 times x. Again, using the rule for quotient of absolute value, we have absolute value of x minus 3 over absolute value of 3x. But 1 over this, 1 over absolute value of 3x is, which is what? 1 over 6. So this can be changed into what? By 1 over 6, then we have, this is less than or equal to what? Absolute value of x minus 3 over 6, which is less than epsilon. Whenever what? 0 is less than x minus 3 less than that. Now here, multiplying both sides this term by 6, then we have that absolute value of x minus 3 is less than 6 times epsilon. Whenever this 0 is less than, absolute value of x minus 3 is less than delta. So by comparing the right and the left hand here, absolute value of x minus 3, absolute value of x minus 3 less than delta 6 epsilon less than delta. Therefore, our delta should be what? Our delta should be, previously we assume that our delta 1 as 1. Now here we choose our delta 2 as 6 times epsilon this. So our delta should be the minimum of delta 1 and the delta 2. So let us assume our delta as minimum of 1, 6 epsilon. So let us check this. For any epsilon greater than 0, then delta is minimum of 1,6 times epsilon. If 0 is less than absolute value of x minus 3 is less than epsilon, then absolute value of 1 over x minus 1 over 3 is equal with absolute value of the whole 3 minus x over 3x, which is the same as absolute value of x minus 3 over 3x, which is the same as absolute value of x minus 3 over 3 times absolute value of 3 times x, which is less than or equal to 1 over 6 times absolute value of x minus 3, which is less than or equal to what? 1 over 6. That means less than or equal to epsilon, as we have said, isn't it? So 1 over 6 times epsilon, but 6 is cancelled by 6, or 6 divided by 6 which is 1, then we have this is equal with epsilon. So therefore limit of 1 over x as x goes to 3 is 1 over 3. Thanks for watching my video, but don't forget to subscribe, like, comment, share my channel.